screen is positive. That means you have an unidentified antibody in your patient's plasma, which means the screen just tells you it's there. Now we have to identify it. Your next step is a panel. When you do a panel, they can be anywhere from 8, 16, 20 panel cells. Pick whatever panel you've got. You want to make sure that the lot number agrees with the antigram that you have, agrees with the panel you're performing, and also that your expiration date, so your panel is in date, not expired. Okay? So the first thing you have to ask yourself, of my antigens, which ones are dosers? Who doses? C and little c, big E and little e, Duffy A and Duffy B, Kid A and Kid B, MN and S and S. Okay. Because they dose, we can only eliminate them on the homozygous cell, which means they have 2 big C's or 2 big or little E's, or homozygous. You can only eliminate on a negative cell. So you've run this panel exactly like you did the antibody screen in an IAT procedure. You have immediate spin reactions, 37, AHG, and of course if your AHG was negative, you ran check cells. It has to be negative in all phases in order to eliminate. If it is a positive in any phase, you cannot eliminate. That means you have an antibody in your plasma to the antigen that that donor possesses. So you see with the first cell, I have a positive in my AHG, right? So that cell we cannot eliminate on. So you want to go to your first negative cell. So cell number 2, you see I have negative immediate spin, negative 37, negative AHG. Okay, that's the first question you're going to ask you. So what is negative over here has the antigen over here, which means I do not have an antibody in my plasma that matches any of the antigens that are positive on that cell. So my D is positive, my antibody screen, or my panel is negative. I can eliminate D. It does not dose, therefore the patient does not have the antibody in their plasma that will bind with that antigen. Big C is positive on the antigen, but what is little c? Positive. So that means they are heterozygous. They are dosers. I cannot eliminate on a heterozygous cell. So big C and little c, I cannot eliminate. Okay? Who else is positive? Kid A. It is a doser, but what is Kid B? So that means Kid A is homozygous. So you can eliminate it. Okay? How about big S? Big S doses with little s. But big S is homozygous. So you can eliminate it. Okay? Then you need to go down to your next negative cell. Number 3 is positive in the AHG, so I have to ignore it. Number 4 is negative. Then once they're eliminated, you do not have to look at them again. Now big C is positive on a negative cell. Little c is negative, so that means my big C is homozygous, so I can eliminate it. Little c can't do anything. Big E is homozygous because little e is negative, so I may now eliminate it. Okay? Cal does not dose, so it does not matter if big K and little k are both positive, right? So I have a negative cell. I can eliminate Cal because I do not have the antibody to that antigen. I can eliminate Solano because I do not have the antibody to that antigen. It is not a doser. Okay? Duffy A is negative, but Duffy B is positive, which means Duffy B is homozygous. So can I eliminate it? Yes. Okay? Now I have Kid, and again we've already eliminated Kid A, but I cannot eliminate Kid B because kid B and kid A are positive on this cell, which means they are heterozygous. Okay? Can't do anything with the little s either because, again, heterozygous. Go down to our next negative cell, which is cell number 5. And look at who you have not crossed out. Little e I can't do anything with because big E is positive on this cell, which means they are heterozygous. Duffy I can't do anything with. Okay, now look at JKB. JKA is negative, JKB is positive, which means JKB is homozygous. I can now eliminate it. Can't do anything with M and N. Okay, now little s. Big S is negative, little s is positive, which means little s is homozygous, so I can eliminate it. Okay, then you go down to your next negative cell. And again, once it's eliminated, you do not have to go back. Little c is now homozygous because big C is negative, so I can now eliminate it. Duffy, can't do anything with that one. M and N, still heterozygous, can't do anything. S is already gone. Go to my next negative cell. Who do I have left? Little e, still heterozygous, can't do anything. M and N, still heterozygous, can't do anything. Go to your next negative cell, which is your last one. Little e is negative, so I can't eliminate it. Oh, I'm sorry, I missed cell number 7. That's where I can eliminate letter E. Here it is homozygous, I'm sorry. So I can eliminate little e on cell number 7. Go down to cell number 10. Who do I have left? Can I eliminate N? Yes, I can eliminate N. Because again, it's homozygous. Okay? So now I've done all my panel cells. Now you need to go back to the top. Who have I not eliminated and you want to circle them? So Duffy A and M are the only 2 I have not eliminated. Now you want to look at your reactions for Duffy A and your positive reactions on your for your panel and who matches. So number 1 is positive for both, number 3 is positive for both, 6 is positive for both, and 9 is positive for both. Let's look at M. M is positive on 5 and we did not get a reaction. M is positive on 7 and we did not get a reaction. And 8 is not a reaction. So it matches Duffy A's pattern as far as which cells have that antigen. So what you're going to say to yourself, Duffy A is my most likely antibody present, but I cannot rule out anti-M.
Thank you.
Okay. Sorry.